Am I the only one who didn't know about a mysterious object near the sun? It's a question that's been quietly echoing through online forums and astronomy circles, sparked by a series of truly baffling images. At first glance, you might dismiss it. Our star is a chaotic, dynamic place, constantly throwing out plasma and energy. But the more you look at this, the more you realize something is different. This isn't just a random flicker or a camera glitch that disappears on the next frame. This is a persistent anomaly, a dark shape lurking in the most extreme environment in our solar system, the sun's corona, a region where temperatures soar to millions of degrees. This is wild, and the more we dig into it, the wilder it gets. We're talking about an object that appears to defy easy explanation, captured not by one, but multiple solar observatories. So, here's what we know. To understand this mystery, you first need to know who's watching. For decades, humanity has had a fleet of robotic eyes fixed on our star. The Solar and Heliospheric Observatory, or SOHO, has been our steadfast sentinel since 1995, providing a constant stream of data. Then, there are the stereo probes, a pair of spacecraft that orbit the sun, one ahead of Earth and one behind, giving us a crucial three-dimensional perspective. And of course, there's the trailblazing Parker Solar Probe, a mission that is literally touching the sun, flying directly through the corona to sample its secrets. These instruments are designed to study solar flares, coronal mass ejections, and the solar wind. They were not designed to hunt for unknown objects. But their constant, unwavering gaze means that sooner or later, if something unusual is out there, they are going to see it. And it seems they have. Across multiple observation cycles, telescopes picked up an object buzzing close to the sun. The initial reports were cautious, as they should be, but the object kept showing up. It appeared in images from different instruments at different times, ruling out a simple, one-off error. The first thing scientists tried to do was classify it. Is it a known celestial body? Let's start with the obvious. It's not a comet. Sun-grazing comets are common, but they have distinct features. As they approach the sun, the ice on their surface vaporizes, creating a bright, fuzzy cloud called a coma, and often a long, streaming tail. This object has none of that. It's a sharp, dark silhouette. Okay, so it's not a comet. Is it a planet? Absolutely not. We know the orbits of all the planets and dwarf planets in our solar system with incredible precision. This object's path doesn't match any of them. Plus, its apparent size and proximity to the sun just don't fit the profile of a known planet. So, we're left with something else, something unusual. And this is where the data starts to get really interesting. The object isn't just a passive, inert rock. It emits weird light patterns. This is a key observation, studied through a technique called photometry. Scientists are measuring the object's brightness over time, and they're finding that it isn't constant. It appears to pulse or flash in a structured, non-random way. This is highly peculiar. Natural objects can vary in brightness if they're tumbling, but these patterns seem different, more organized. And then there's its movement. It moves unlike normal solar debris. The space around the sun is filled with particles and plasma, all flowing outward with the solar wind and shaped by the sun's immense gravity and magnetic fields. This object, however, doesn't seem to be just passively drifting. Its trajectory appears to be slightly, but measurably, different from what you'd expect from a simple piece of rock or ice caught in the sun's grip. It's these subtle deviations that have astronomers scratching their heads. Now, before we get carried away, it's time for a reality check. The scientific process is one of elimination. The first and most important step is to try and prove that what you're seeing isn't real. Could this all be an instrumental artifact? A ghost in the machine? Absolutely. Space is a harsh environment for cameras. A high-energy cosmic ray can strike a sensor and create a bright streak that looks like an object. The intense light from the sun can saturate pixels, causing blooming effects that create strange shapes. There are also phenomena like rolling shutter, where fast-moving objects can appear distorted in digital images. This is why having multiple observatories is so critical. NASA is tracking it, the European Space Agency is tracking it, and private and university-led observatories are all poring over the data. They use a technique called parallax. If the object is real and close to the sun, it will appear in a slightly different position when viewed from the Stereo A spacecraft versus the Stereo B spacecraft, or SOHO. If it's just an artifact in one camera, it won't show up in the others, or it won't exhibit this parallax effect. So far, the evidence is leaning towards a genuine physical object. The data from different sources seems to correlate. With the possibility of it being a simple glitch reduced, the analysis deepens. They're analyzing spectra. This is where things get really fascinating. Spectroscopy is like a chemical fingerprint. By breaking down the light from, or reflected by an object, scientists can determine what it's made of. Is it rock, metal, ice? The initial spectral readings are challenging due to the overwhelming brightness of the sun in the background. It's like trying to hear a whisper in the middle of a rock concert, but the preliminary data is tantalizingly ambiguous, not perfectly matching any known type of asteroid or comet. At the same time, they're analyzing orbits to rule out glitches or known objects. Teams of orbital dynamicists are running complex computer simulations. They take the object's observed position and motion, and try to calculate its past and future path. They're trying to answer key questions. Is it in a stable orbit around the sun, or is it on a one-way trip, destined to be ejected from the solar system or plunge into the sun? These calculations are incredibly complex, and the slightest uncertainty in the measurements can lead to vastly different outcomes. But every simulation that points towards a stable, repeating orbit makes the object that much more significant. So, what are the leading plausible theories? The most conservative and likely explanation is that it's something natural, but rare. Early theories pointed to stray asteroid fragments. Perhaps a larger body broke up long ago, and this is a remnant on a peculiar orbit that brings it perilously close to the sun. It could be made of highly heat-resistant metals and rock, allowing it to survive where other materials would vaporize. This is a strong contender. Another possibility is that it's a strange type of comet, one whose outgassing is happening in an unusual way that doesn't produce a visible coma. Or maybe it's an extinct comet nucleus, a dead chunk of rock and dust, that has lost all its volatile ices. There are also purely solar phenomena to consider. Could this be a dense knot of plasma, a form of coronal rain that's behaving in a way we've never seen before? The sun's magnetic field is capable of creating all sorts of bizarre structures, and we are still discovering new things about it. This is where we must be careful and exercise healthy skepticism. It's easy to jump to conclusions, but science demands patience. And then, of course, there's that tiny spark of sci-fi curiosity, the idea of an unknown class of solar traveler. It's important to state this clearly. There is currently zero evidence to suggest this is anything artificial. Zero. But the structured light patterns and unusual trajectory are anomalies, and the job of science is to investigate anomalies. Could it be a probe from another civilization? A piece of technology so advanced it can withstand the inferno of the corona? It's an extraordinary claim, and it would require extraordinary evidence, which we simply do not have. For now, this remains firmly in the realm of speculation. But it's a speculation that fuels our drive to find the real answer. So let's bring it back to the facts. Bottom line, it's real. The consensus is growing that this is not a camera artifact. It is a physical object or phenomenon located near the sun that has been detected by multiple independent systems. That alone is a significant finding, and it's being actively studied. Right now in labs and universities around the world, scientists are writing code, running simulations, and booking time on other telescopes to get a better look. They're trying to get more detailed spectra, more precise photometric data, and longer-term tracking to nail down its orbit. Every new piece of data is a piece of the puzzle. The implications are profound, no matter what the answer turns out to be. If it's a new class of asteroid, it tells us more about the formation of our solar system and the materials that can survive in extreme environments. If it's a new type of solar phenomenon, it opens up a whole new chapter in heliophysics, the study of our sun. The answers could reshape near-sun science. It would mean our models of the corona are incomplete. And there are processes happening right on our cosmic doorstep that we never knew existed. This is how discovery works. It rarely happens in a single eureka moment. It happens through careful observation, rigorous analysis, and the patient elimination of possibilities. What we're witnessing is the scientific process in action, grappling with a genuine mystery. We don't have the final answer yet, but the search for that answer is pushing the boundaries of our knowledge. Follow for updates. This mystery is just getting started.